Once upon a time, there was a composite filament winding machine called the X-Winder and a naive Capstone team that thought they could fix it. This team was made up of 6 members of the Society for Advanced Rocket Propulsion, also known as SARP. SARP is a student organization at the University of Washington dedicated to developing high-performance rockets that incorporate technologies and processes relevant to the launch industry while building student engineers' skills. The optimal nose cone profile depends on the flight profile of the rocket, which is highly variable during the rocket's design phase. Currently, SARP nose cones are manufactured by laying up 2 nose cone halves on a female mold using pre-preg fiberglass. These halves are then combined with a wet layup lap joint. This process is time-consuming, highly prone to human error, and requires expensive molds that cannot be easily redesigned to accommodate nose cone design iterations. Shown here is SARP's solid propellant-powered rocket with the only nose cone shape that can be manufactured using SARP's existing manufacturing abilities and materials. This nose cone was optimized for a longer, liquid bipropellant rocket with a different flight profile. Shown here is the same rocket with a nose cone better suited for its length and flight profile. This flexibility and nose cone design would be enabled by our process. The X-Winder is a desktop glass or carbon fiber filament winder and was proposed as the basis for an alternative nose cone manufacturing method. This winder was previously used to manufacture skirts for SARP's composite tanks. Our proposed manufacturing process consists of laying composite filament over a 3D printed mandrel. This mandrel is then dissolved out after curing, leaving only the composite layup. This is then trimmed and sanded to produce a final flight-worthy nose cone. The X-Winder has proven to be extremely unpredictable and unreliable. Wind attempts consistently fail as shown here. Even when executing the same G-code, the X-Winder will fail in different places. Here, the delivery head deviated from its intended toolpath and collided with the mandrel. Here, the delivery head seizes up and moves too far inwards.
Bruh.
Our initial challenges printing dissolvable filament were eventually solved. Despite the X-Winder's limitations, our process for manufacturing nose cones would still be operational if a better filament winder was acquired. All other stages of the manufacturing process were tested and verified, including mandrel production, dissolvability, and post-processing. We'd like to give a special thank you to Alvar for his guidance and support, Kevin from the Chemistry Machine Shop for his hands-on expertise, and Cadwine for the generous software donation.